Okay, so will someone tell me, do you see notes, summary of notes year 12 mechanics on the screen?
Yeah.
Yeah.
Okay, that's good. Okay, so first of all, we will look at how to combine velocities, and question could be a plane might be flying in this direction with a certain velocity, and wind might be blowing in that direction, and you might be asked to calculate the actual or the true velocity. So how we will do is we will draw velocity A, add velocity B to that, and then from the tail of the first to the head of the second, that will be the resultant velocity. You can do draw B and then draw A first. It will give you the same answer, same size and same direction. So then you use Pythagoras to calculate the size of this true velocity, and to calculate the angle, you can use geometry. Tan theta is opposite over adjacent. So that's how we do the addition of velocities or addition of any vector quantity. Subtraction is when we want to find the change in velocity. So for example, an object might be moving with a certain velocity in that direction, and then it makes a right-hand turn like that. So if that's the initial velocity and that's the final velocity, then and you will be asked to find the change in velocity. So change in velocity is always final minus initial. So that means we need to draw a negative initial velocity. So if this is the initial velocity, that will be the negative initial, same size, opposite direction. Then we draw final velocity, add negative initial velocity, and from the bottom of the first to the tail of the second, that will be the change in velocity. So it's always final minus initial, not this and that. And if you draw A and then B from there, that will be the addition of velocities, not subtraction of velocities. And we cannot do B minus A either, because B minus A gives you that answer, which is in the opposite direction to that. So you have to look at which one is the final, which one is the initial, and use that one. So to find the size, you will use Pythagoras, a square plus b square equals c square, and use tan theta to find this angle in this triangle. So that's about the change in velocity. Another thing you could be asked is about the velocity component. So for example, a plane might be ascending from an airport, and that's its velocity in this direction. So what it means is plane, as it's rising, is gaining height. It has got a vertical velocity and a horizontal velocity. You know, like you go in a plane and you see a dot on the screen in a plane, and that dot shows you that how far you have moved from the starting position. Okay, so that's what the velocity of this one represents. And if this is your actual velocity, then in this triangle, if you look at this triangle, this is the opposite side, which is same as vertical velocity. This is the adjacent side. So for adjacent side, we always use cos of the angle. So adjacent velocity, V horizontal, will be V times cos of theta. And this is the vertical or the opposite side. So opposite side will be sine theta. So these equation can be used to find in horizontal and vertical velocity. And where do we use most of these one is in projectile motion, which I will explain in a minute. But before that, we look at kinematic equations. So kinematic equation is, if something is moving with a constant velocity, then this is the formula to use, V equals d over t. However, if something is accelerating or decelerating, then we use this set of equation. V final, V initial, acceleration, and time. And in all of these three equations, four things are given. And there are four variables or four quantities. You will be given three, and you will be asked for the fourth one. So in this one, there's no final velocity, but distances. In this one, there's no time. If something is decelerating, then you make the acceleration as negative. So These equations can be used if an object is moving in a horizontal direction with an acceleration, or if an object is moving down or up in a vertical direction. Only thing is that acceleration will be 9.8. Positive on the way down, negative on the way up. So these equations can be used for these ones, but most often you will be asked question in projectile motion. And what is a projectile motion? Projectile motion is when something is moving only under gravity. So if there is a ball and you throw it at an angle, then it will follow this path. Now, if you look at each and every point, so that was the actual velocity it was thrown at. Using the same as I mentioned before, we can calculate the horizontal component and the vertical component by using these formulas. If you notice here, horizontal velocity remains same and it remains constant because friction is negligible. So we ignore the friction, or we say there are no external forces on horizontal direction, so horizontal velocity remains constant. However, if you look at the vertical velocity decreases on the way up and then increases on the way down. Reason is, on the way up, gravity is acting against the motion. And on the way down, gravity is acting in the same direction, so vertical velocity increases. So here, when the ball hits the ground, that will be the true velocity. And if you look over here, it's different from this direction, but the size of this one will be same as that one, because horizontal velocity remains constant and vertical velocity will be same as this component here, only direction is different because it travels the same distance up and same distance down, and gravity was constant. So again, using Pythagoras, we can calculate this one, or you can simply say this is same as that one, except the angle direction. Is everyone following so far?
Yeah.
Okay. So what you will be asked in these type of question is that how far does the ball land? So that means you will be asked this distance. So this distance will be horizontal velocity times total time. Now, time to go from here to there is same as time to come from here to there. So total time will be twice for the time for the upward flight. And so first of all, what you will need is you will need to find the time for the upward flight. Just go from here to there. So here, final vertical velocity is 0. Initial vertical velocity will be whatever you have calculated for this one. Acceleration will be negative 9.8. So using this equation, you can find the time, because you know acceleration, initial velocity, final velocity. In the vertical direction, you can find time. And multiply it by 2. That gives you total time. And so V horizontal times total times give you distance. If they ask you how much is the total height reached from here to there, again, we will use vertical velocities. And so we have to find that distance from here to there. And it's the vertical velocity which is taking it up. So we will use this kinematic equation here. So if we know the initial vertical velocity, we know the time of the flight that we calculated earlier. Acceleration will be negative 9, and that equation can be used to calculate the time. So that's so that's all about the motion topic. Is that okay if I move on quickly to now forces part?
Yeah.
Okay. So forces. So in forces part, we will look at balanced and unbalanced forces, and mostly question will be on a ramp. So if an object is either stationary or it is moving down or up the ramp at a constant speed, we will say forces are balanced. Now, what are the forces? So this is the blue box. Gravity force always externwards, and that's always the largest force. If this ramp was flat, not at an angle, then support force will be equal and it will be upward like that. Okay. But now, because of the angle, support force has become less. So this will be the largest force. If this block is stationary here, that means there is a friction force which is holding it from sliding down. Or it could be moving with the constant speed. So all these three forces, they are balanced. And to find out, if we are given the mass, we can calculate gravity force, m times g. And now the question will be asked is calculate the size of this force and that force. And so we will use closed triangle method. And what is the closed triangle method? Is that we draw the gravity force first. From the tip over here, we draw the friction force, because friction force was up the ramp here. And then support force was here, so we draw the support force. So we started from here, and when add three forces, it becomes where we started. That means result is 0. Okay. Now, angle between the friction force and the support force, you can see from here too, is 90 degrees always. So in this triangle, that's the 90 degrees angle. Now, this angle is same as that one, because remember, this angle over here is 90, this angle is 90, so this one is 90 minus theta, so this one becomes equal to that. So if you know this angle and you know this one, gravity force, then this will be the opposite side, and opposite side will be mg, which is weight force, times sine of theta, and this side will be adjacent side, and it will be mg times cos theta. So you can use this equation and this diagram to find the these two forces if you know. But quite often they will ask you to draw it first and then calculate it. Now, it doesn't matter. Instead of doing the friction force first, you could go this way. Draw the weight force first, then support force in this direction, and the friction force in that direction. But you need to have the look that you should end up where you started. So the resultant force is 0. So those were balanced forces. To look at the unbalanced forces, this object might be coming down with an acceleration. So that means these three forces are not balanced. And to find the size of the unbalanced force, if it's coming down, then size of the unbalanced force will be downwards. Now, these three forces don't add up to 0, but we will use component method for that. So we draw this one force, which is the largest force first. Okay, and then we draw the two components. Okay, so that's the gravity force. And then F1 and F2 are two components. So this one can be replaced by these two. Friction force and support force are there. Now, since the object is not bobbing up and down, that means these two forces are equal and opposite, so therefore they're balanced. Now, F1 comes out more than FF because the object was accelerating. And how do we find the unbalanced force? Unbalanced force will be F1 minus FF, which gives us this thing, F1 minus FF, and unbalanced force is always mass times acceleration. So if you've calculated this one, you can calculate the acceleration. Now, torque is the turning effect of a force. So if you apply a force, this object will turn clockwise, or a force is producing a torque, and torque is force times distance. It could be clockwise. If you push it up, it will be anti-clockwise. If you push it at a greater distance, then torque will be greater. If this distance is longer, torque will be greater. Unit is Newton meter. Now, what is the rotational equilibrium? Now, linear equilibrium is when object moves at a constant speed, either down the slope or horizontally, and then forces are balanced. Rotational equilibrium is when something is moving round and round at a constant speed, or it is stationary. So that's called the rotational equilibrium. An object is either stationary or it rotates with a constant angular speed. Now, rotational equilibrium, there are two conditions for the rotational equilibrium. So the first one is, and we will look with an example. So if there's a seesaw or a plank, and Katie and Amy are sitting, and the seesaw is balanced, then downward forces will be weight of Katie, weight of Amy, weight of plank. So these are the three downward forces. Support force will be coming from the pivot. If this pivot is not strong enough, the whole thing will collapse. So if this seesaw is balanced, that means upward force is equal to these three forces, or they are balanced. And we write it like that. F1 plus F2 plus F plank equals F support. So that's the forces rule. Second rule is the torque rule. So Katie is creating an anti-clockwise torque, which is F1 times D1. Amy is creating a clockwise torque, which is F2 times D2. These forces don't produce any torque because distance is zero. That's the pivot. So second rule for rotational equilibrium is the torques are balanced. Anti-clockwise is equal to clockwise torque. Okay. Now, rotational motion. Now, is everyone following so far?
Yeah.
Listening does? That's good. Okay. Sorry, I'm going a bit faster because of I'm aware of the time. So now, if ball is moving at a constant speed, and this is the radius r, that means its direction is changing. It's always along the tangent. So at this point, it will be somewhere along here. Over here is changing. So this is the constant speed. But because its direction is changing, that means velocity is changing. And if velocity is changing, that means there is an acceleration. And if there's an acceleration, there must be a force. And force and acceleration are always in the same direction. So what is providing this force is the friction on the track, if this is a toy car. If it's a kind of a rock or something at the end of a string, then it will be the tension force. So tension force is towards the center, or friction force is towards the center, and it provides the centripetal force because it's 90 degrees angle. If the force was in this direction, it will accelerate it. If the force was in this direction, it will decelerate it, but not change the direction. It only changes the direction if it's 90 degrees, and that's what happens in here. So in this question, what you could be asked is, calculate the acceleration. So these are the formulas. Centripetal acceleration is v square over r. Friction force is providing the unbalanced force or centripetal force, and that is equal to ma. And a was this one, centripetal acceleration. So it becomes mv square over r. So that might look familiar. Centripetal force is mv square over r. If an object is moving with a constant speed, then distance traveled is the circumference, which is 2 pi r. So speed will be distance over time, 2 pi over t. So time for one rotation is called period. So that's what the period is. And we can rearrange it to find the period. Now, just to show you this little thing. Okay. Now here, car will be moving when I get it started at a certain speed, which has been set here at 40 meters per second. That's the weight force, and that's the support force. So they are canceling each other. It's not bobbing up and down. And friction force is providing the centripetal force. So in this path, let's see what happens when we start the animation. So friction should be large enough to provide the centripetal force mv square over r, and car makes. So that's all right. Reset. Now this time I'm going to decrease the friction. So I'm decreasing the friction, or I can increase the speed of the car, but let's say I will just decrease the friction, make it quite small. So now friction force is only tiny from here to there, 30 to 100 3,200 newtons. Let's see what happens. Now friction is small, quite small. So if friction is not large enough, car will not be able to stay on the circular path. It will move along the tangent at that particular instant. Okay, so that was okay, that has taken me right back. So that was all about the forces part. And then we come down to the last part, which is momentum and energy. Is everyone okay so far, or not too much?
Yeah.
Okay. So momentum is mass times velocity. Mass has to be in kilograms. The unit is kilogram meter per second. It's a vector quantity, so it has got both size and direction. Now, you will be asked what happens in a collision between two objects. So law of conservation of momentum says that total momentum of the two objects before the collision is same as the total momentum after the collision. So in this example, red car had a momentum of 30, this one had a 20, so total initial momentum was 50. After the collision, this one has a 20 and this one has gained and 30 now, so it's 50 again. Now, so in real life, you may not be given this object and you might have to find the velocity of this one after the collision. So we use this formula over here. M1 V1, which is this object, first object. M2 V2 is this one. This is after the collision. And so if you're not given this one, we can use this equation because we know all these three things, we can find out this one. So that will give us the momentum. And if we know the mass, we can calculate the velocity. Now, sometimes, these two objects collide together and get joined together, like move as one object. They clip together, or sometimes this might move back in this direction. So you have to take, if it is moving back, then velocity will be negative, but that's the basic equation that you will be using for all these momentum. So what we are saying is that momentum is conserved in all collision. Condition is there should be no external forces, no friction, nothing. So that's first thing. Second thing is the change in momentum. Now, if we look at this one, momentum of the blue car was 30 after the collision, initial was 20. So how much is the change? 10 in that direction. It has gained 10 kilogram meter per second. The blue one is final is 20 minus initial 30 is negative 10, which is 10 in this direction. So if we draw a vector, then change in momentum of the blue will be in that direction, change of the momentum will be in that direction, but they're always equal and opposite. And so that's the rule, the change in momentum of two objects is equal and opposite. And what's the reason for that? Now, change in momentum is called impulse. Delta P is V final minus V initial. And how much will be the force during that impact? Now, impulse is force times time. So if time of the impact is given and we know the change in momentum, we can calculate the force. So in a collision, forces, action and reaction forces are equal according to the Newton's third law. So if action and reaction forces are equal, and that's the reason that change in momentum is also equal. So that's the change in momentum of the blue car, and that was the change in momentum of the red car. They were equal, but in the opposite direction. And remember that impulse equation, delta P is F times T, and delta P is also P final minus V initial. So that's the change in momentum. Now, what are elastic and inelastic collision? There are no external forces. Momentum is conserved in both type of collision. But kinetic energy is conserved in elastic collision, but not in inelastic collision. And using this formula, you can calculate the energy before the collision and after the collision, and then figure out whether the collision was elastic or inelastic. Now, work done is force time distance, but only when the force is constant, not when the force is changing. And work done changes into energy, energy can change into work done. There are gravitational potential energy, that's for the kinetic energy, and that's for the elastic potential energy. And energy is conserved. What it means is if an object drops, like for example, a ball from a certain height from here to there, its gravitational potential energy changes into kinetic energy. There might be a little bit heat produced, but total energy is conserved. Power is work done divided by time, or how much is the energy change in 1 second. Unit is watts. Now, last thing, it won't take long, is the energy in a spring. So first of all, we need to know what's the force constant. Now, force constant of a spring can be soft springs or stiff springs. So if it's easier to stretch a spring, then we say it has got a lower spring constant. If you require more force to stretch it, that will have a high spring constant. And what is spring constant equal to? Force divided by x. So if we draw a force extension graph or force compression graph, this could be extension or compression, then gradient F over x gives us the spring constant. Now unit is Newton per meter. Remember for torque, it was Newton meter. So this unit for spring constant is Newton per meter. Now what's the energy in a spring? So a spring is stretched or compressed. It will have elastic potential energy. How much will be, so when you release a spring, all that energy can change into kinetic energy. For example, when a gun fires a bullet, elastic potential energy changes into kinetic energy. And how much is the energy stored in a spring? It's half kx squared. X is the extension or compression, k is the spring constant, and that's the formula. In terms of graph, you could be given information in terms of kind of data or in terms of graph. So if it was given for F an extension graph, then it's the area under the graph. And why we cannot use force time extension? Because force is changing. So F times D can only be used if force is not changing, but here the force is changing. So you have to use area under the graph. And if we change that area under the graph, F, so it will be base time height, and if we put the value of S as kx, it gives us half kx squared. So basically, that was all that I wanted to explain. So thank you for your patience and all that. Okay.
Miss Khan,
Yeah.
for exams, do we get the formulas given to us, or do we have to remember them?
No, you remember I put in one of the lesson, I put the resource sheet for formulae. I think it was last week or week before.
Okay.
So all the formulas are given on one sheet. I think it's 1 page or 2 pages. So all those formulas will be given. Okay.
Thank you.
Some formulas, like distance equals speed time. Speed is distance divided by time. That might not be given. Very basic one. But generally, all the formulas are given.
Okay.
Any questions, guys, about the notes that I've explained? Is it all good? Or you can turn on I can stop the recording now. So you can turn on your camera so we can see who is here.